covalent? Covalent. So we know we've got a covalent thing. And look at that. It even tells us the particles that would be in Avogadro's number, because you always have to look at the substance. So we know CO2 is covalent. We know the particles in Avogadro's number. But it doesn't want that information. It wants the number of carbons. But you just said, Stefan, there's one carbon in every molecule. Right? You said that. You said there's one carbon, two oxygens. Yeah. So what if I take this number and I multiply it by one carbon atom for one molecule? What do you think? Stefan?
Sorry,
What is going to happen? What are my units? You don't need your pencil to do this. No, you don't need to write this down right now because I'm asking you a question. Look, what's going to be my units of my answer for this? What happens to a unit that's on the top and the bottom? Cancel out. So what cancels? Molecules. So question, write down what you've got. You always know molar mass. You just have to calculate it. You always know Avogadro's number. Okay? So we want the mass of the sample. Don't write this down yet. Stop. Stop. Pay attention. You can't do two things at the same time. You think you can, but you can't. Okay. Yeah. Do I need proof? I got proof. Okay. So, mass of sample. What is the unit we're looking for? What's the unit for mass? No. What's the unit? Grams. So we need the number that has grams in it first, and grams have to be on top. Okay. We want to get rid of moles. What else up there has moles in it? Avogadro's number. But we need to flip it so that the moles cancel. Don't forget the second ratio. What's on top has to be on the bottom of the first ratio. So moles. Okay? Stefan. Okay. So now moles cancel, but I've got molecules. I want to get rid of those, but I've got that. Okay, so now molecules are gone. No formulas. I just had to write down the three pieces of information. One was given, two I know. Use them to get my answer. You will not, bless you, you will not make a mistake rounding off an answer prematurely. You will not forget to put in your units. So this is a good way to do it. So now, figure out the answer, and you can start writing it down. Stefan. Figs, can you have in your answer? 2. So I've got to go from 307.05 to only 2 numbers. So, and I can only have 2 numbers. 3.1 times 10 to the 2 grams. Yeah, or 310 grams. I can only have 2 significant digits, so the 7 has to round up the 0. Okay, so 310 grams. Formulas. First, you have to use, guys, be courteous. First, you have to use this number, this relationship, because you know big N. You know big N in Na, so you can solve for the number of moles. Make sure you have more than 2 significant digits. Then, because you have this formula, you can now solve for mass. So this number of moles is inserted here. Okay, and you should get the same answer. How many times does a 2-liter balloon fit into a blimp? So you take the volume of the blimp, divide it by the volume of the balloon. And what number do you get? It's a pretty big number. What'd you get? 2,870,000. That number? No. One more zero. Times that by your answer from A. Okay? So how many helium atoms did you have? So you take, it's this many times bigger, so it contains that many times atoms. So it's going to be a monster number. Okay? So it's going to be what? 1, 2, 3, 4, 5, 6. It's going to be about times. It's going to be about 4 times 10 to the 35. Look at that. Did it without knowing the answer. Because I took, that's almost 3, 2.8. That's almost 3. 3 times 1.4 is about 4, 4.2. And I've moved the decimal place for 2 million, 6 decimal places, so I added 6 to my 29. Okay. 11s.